began with a storm. Off the coast of a small Greek island called Antikythera, a group of sponge divers in the year 1900 sought shelter from rough seas. To pass the time, they dove down into the depths. What they found wasn't just a sunken Roman ship, it was a time capsule. A shattered vessel, lost for over 2,000 years, filled with marble statues, bronze artifacts, and pottery. Among the ruins was a strange, unremarkable object, something most dismissed as a corroded lump of metal and wood. Just another relic. But hidden within that mass was a secret. It's a mechanism, a machine. And what it represented would challenge everything we thought we knew about ancient technology. We now call it the Antikythera mechanism. And it might be the world's first analog computer. For over a year, the object sat unnoticed in the National Archaeological Museum of Athens. No one knew what it was until a Greek archaeologist named Valerios examined it closely. He spotted something strange. Gear teeth. Then more gears. Dozens of them. It was a discovery that shouldn't have been possible. This object, dated to around 100 BCE, contained advanced gearing, something we believed didn't exist until at least the 14th century. The gears were precise, interlocking, layered. And yet, here they were, inside a corroded box from the ancient world. The mechanism had been found on a Roman cargo ship, likely traveling west with goods from the eastern Mediterranean. There were luxury items on board. Glassware, statues, coins. Whoever owned this machine wasn't a common citizen. They were wealthy, educated, perhaps even connected to the scientific elite of the time. The device itself, though, wasn't decorative. It was functional and brilliant. When X-rays were first used on the fragments in the 1970s, researchers uncovered more than 30 bronze gears. Some were tiny, others massive. Some rotated around other gears. Some were stacked with astonishing precision. It used complex systems, cyclic gearing, differential motion, nested axles, all of which wouldn't be seen again for over a millennium. But what was its purpose? The real breakthrough came in the early 2000s, when a team of scientists, led by the Antikythera Mechanism Research Project, scanned the fragments using higher-resolution 3D X-ray tomography. What they found was nothing short of astounding. Carved into the interior plates were thousands of Greek characters inscriptions that included calendar systems, astronomical data, and mechanical labels. The device wasn't random. It wasn't decorative. It was a machine built to predict the cosmos. The Antikythera mechanism could track the position of the Sun, the Moon, and the 5 known planets: Mercury, Venus, Mars, Jupiter, and Saturn. It modeled the Metonic Sakola 19-year period that aligns lunar months with solar years. It accounted for the Saros cycle, which predicted eclipses. It even included the Calippic cycle, a 76-year refinement of the Metonic rhythm. By turning a small crank, the user could simulate celestial motion across years. On one side of the mechanism was a dial that displayed the zodiac and the solar calendar. On the back, 2 spiral dials tracked eclipses and lunar phases. Inscriptions noted the timing of ancient festivals, most notably the Olympic Games. And here's where it gets eerie. The machine didn't just simulate planetary movement, it corrected for it. The mechanism accounted for the Moon's irregular orbit, a concept not formally explained until the work of Kepler and Newton. More than 1,500 years later, this required not only observational knowledge, but mechanical ingenuity. The device used a pin-and-slot mechanism to mimic the Moon's variable speed, something no other ancient device is known to have done. Think about that. A Greek engineer somewhere between 150 and 100 BCNU, enough astronomy and mechanical design to model elliptical motion using bronze gears. Not a concept sketch. A working, physical machine. That level of sophistication raises an uncomfortable question. How could such a thing be built in the ancient world? And more importantly, why didn't it survive? Some scholars believe the Antikythera mechanism wasn't unique. In fact, Roman author Cicero once described a device created by Archimedes that could replicate the movement of the heavens. He claimed to have seen it in action, predicting planetary positions and lunar phases. That account, long dismissed as exaggeration, suddenly makes more sense. Perhaps the Antikythera mechanism was part of a tradition. A lineage of machines designed by engineers in Alexandria, Rhodes, or Pergamon, now lost to time. Rhodes in particular was a hotspot for astronomy and mechanics during the Hellenistic period. The philosopher Posidonius, a contemporary of Cicero, is believed to have constructed celestial models. Some even speculate that this machine came from his workshop. But the most haunting theory is this. Maybe it wasn't just knowledge that was lost, but infrastructure. Perhaps the Antikythera mechanism was the product of a brief, concentrated window in history when science, craftsmanship, wealth, and political stability aligned just enough to make such a device possible. When that window closed, the knowledge vanished with it. The fall of Greek science under Roman domination, the burning of libraries, the shifting tides of empire, the rise of mysticism and dogma over empirical study, all these factors may have contributed to the silence that followed. What we do know is this. After the Antikythera mechanism, the trail goes cold. No similar device has ever been found. The West wouldn't produce machines of comparable complexity until the 14th century, and even then they were primitive in comparison.
Oh.
That's what makes the Antikythera mechanism so powerful. Challenges our assumptions. We like to believe that progress is linear, that technology builds slowly, brick by brick. We are the apex of all that came before. But this machine whispers something different. It says knowledge can be lost. Genius can be forgotten. Civilizations don't always climb, they sometimes fall. And when they do, what's left behind is often nothing more than fragments. Today, the Antikythera mechanism rests in a glass case in Athens, preserved, studied, admired, but still only partially understood. Engineers have built reconstructions based on the X-rays and inscriptions. Some are fully functional. They demonstrate the complexity and accuracy of the original. And yet we still don't know exactly how it was assembled. The bronze gears were cut by hand, likely with rudimentary tools. But the precision suggests a level of expertise we cannot fully explain. There are still debates about its missing pieces. Some researchers believe the original mechanism had even more functions tracking planetary retrograde motion, star phases, or tidal patterns. Others think it may have been part of a larger scientific toolkit, perhaps one of many machines used in ancient schools or observatories. Whatever the case, it serves as a humbling reminder. We don't know everything. History is not a straight road. It's filled with detours, dead ends, and blind spots. The Antikythera mechanism is one of those moments when a beam of light cuts through the darkness of time, revealing that human ingenuity is not a modern invention. It's ancient, enduring, and far more advanced than we often give it credit for. So the next time you look at a digital screen, or marvel at a spacecraft, or navigate by GPS, remember this. Over 2,000 years ago, someone turned a crank and watched the universe move.